Hello and welcome to York Universe, the astronomy and astrophysics radio podcast, written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm actually joined by a recurring guest who is coming once again, Mahesh Aravamudan, a RASC Toronto Centre member and astronomy enthusiast, for this episode. So welcome back, and we'll go ahead and give everyone the full intro here. We are broadcasting from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT, if that's more your speed. We broadcast live on YouTube at York U Observatory in concert with our online public viewing program run by the Observatory team. After the live broadcast, the podcast is, of course, out on all major platforms. So if you're looking for podcasts on Spotify or Apple, make sure to look up York Universe from York U Observatory, Allan Carswell Observatory. To navigate to the live show or find out more, check out our website, yorku.ca/science/observatory, and follow the links for online public viewing, or click on any of the YouTube links and it'll take you directly to our channel. If you miss the live broadcast and still want to catch online public viewing in addition to the radio podcast, you can always see them. They're all actually recorded. If you have any questions or comments, or of course, if you have suggestions for future topics, please send us an email at observe@yorku.ca. And you can, of course, always connect with us over on the social media. We have Instagram at York U Observatory, PixelFed at Allan Carswell Observatory, and Facebook at Allan Carswell Obs. All of our programs, including this one, are free, but if you'd like to make a donation, please see that same website, yorku.ca/science/observatory, and of course, we do appreciate it. Now, we're monitoring the chat room for questions, and of course, we'll find lots of wonderful content posted, but we have had some real ups and downs in Toronto weather. So let me go ahead and pass over to my co-host, Mahesh. Welcome back to York Universe. How is the weather where you are?
Hi, Elena. First of all, thank you for inviting me again. I'm honored to be here. So yeah, the weather is interesting, great. Actually, the last two nights have been wonderful. In fact, last night I was able to see Jupiter, Venus, and Mercury all lined up. Though it was a full moon, I could still see it around at the twilight time. I was able to see Jupiter and Venus, and then I could even see Mercury once it got a little bit darker. So I trained my telescope to those. I couldn't get Mercury, but I was able to at least get Jupiter and Venus. But it's an interesting observation that you can actually see all three planets all lined up, and it's a beautiful, beautiful image just to capture those three together.
Yes, and of course that would be the conjunction, and it's officially the conjunction for Venus and Jupiter on June 9th. This is June 1st, so we can look forward to a bit more of Venus and Jupiter being together in the sky. Now, you said you used a telescope for your viewing, but you don't have to. If you want to see Venus and Jupiter, they are quite bright up in the sky. Even if you live in a city, or if you're in downtown Toronto, you can usually pick them out. Sometimes they look a little bit like airplanes. Now, if you wanted to get a better view, what kind of telescope did you use for your observing?
I used an 8-inch Schmidt Cassegrain from Celestron. So yeah, I just wanted to get a complete. I haven't seen Jupiter in a while, so I thought I can blow it up a little bit and see the satellites around Jupiter as well. So it was more I could see it, as you rightly mentioned, with the naked eye, but I just wanted to get a close-up look at those, and I was very surprised to see Mercury that high in the sky.
Yes, that's the greatest elongation. As you say, Mercury is really a challenging object to try to get a view of with a telescope because it is, of course, orbiting very close to the sun, which means that every time we look at Mercury, we're kind of looking in the direction of the sun. So
Yeah.
to get Mercury and not the sun in your face is a really big challenge. As you say, this greatest elongation that's coming out, I believe we'll have a greatest elongation east on June 15th later this month.
Yeah. Um, no, that's good. That's good to know. And actually, one thing I'm always afraid of looking at Mercury is I point my telescope and I don't want to point it towards the sun without a filter, right? So that's
Oh
what
yeah,
I'm worried about. All right.
don't don't do
Don't
that.
do that.
So, yeah, if you have
Galileo
a
actually.
yeah,
Oh,
so very bad for the optics.
very bad for the optics. Yeah, for our personal optics. Correct. Correct.
Well, it's I don't know, want to speculate on what sort of damage Galileo did to his
Yeah.
eyes.
Yeah. I know. Yeah. But it's a beautiful scene to see all three lined up, and uh, I believe, as you mentioned, there'll be a conjunction between Venus and Jupiter. I'm looking forward.
Yes, absolutely. And of course, one of the nice things about sky viewing and, what's up in the sky right now is when you have really bright objects, you can use a telescope. But as I say, you don't necessarily have to. But it can bring out just a little bit more detail, and especially something like Jupiter, where you have the Galilean moons of Jupiter, which are the four brightest moons of Jupiter. They go around Jupiter pretty quickly, and if you have a telescope set up, you can actually watch the little dots through your telescope as they move around Jupiter over the course of several hours. Have you
Yeah.
ever had the pleasure of doing that?
Elena, you read my mind actually. Like you're a mind reader. Yesterday, this is exactly what happened. I could see one of the moons go right behind Jupiter, and I couldn't see it either after that. So I didn't wait for it to come on the other side, but I could actually see it traverse right behind Jupiter or in front of Jupiter. I couldn't figure that out, but I could see it completely disappear, one dot disappear behind Jupiter or in front of Jupiter. So exactly, I was about to bring the point, and you brought it. Oh my God.
Yeah, it's really quite fun, and if people are interested in tracking which moons are which, there's even better news because a lot of wonderful tools have been created for amateurs and for astronomers as well. So if you'd like to follow the moons of Jupiter, or actually if you want to follow the Great Red Spot. So if you're watching the surface of Jupiter and you see the Great Red Spot moving, there's actually a Great Red Spot transit calculator and a Jupiter moon tool. The transit calculator is from Sky and Telescope, and the Jupiter moon tool is a different page in the Sky and Telescope tools area. And they're all free, so I only recommend free things. But if anyone's searching for these and has trouble finding them, I've listed them all on our Observatory webpage in the Observers Tools area. So if you're keen to try to catch these for yourself and want to catch a specific moon, you really want to see Io, or you really want to see the Great Red Spot of Jupiter, there's a bunch of tools for those, as well as the Saturn's Moons tool that we've listed for folks. And it is quite fun to be able to actually see them, identify them, and if you're really keen, you can even do the equations to predict their movement.
I used an F10, and the magnification was 80 times, and it was pretty sight at that time, and I could see the bands, the Jupiter bands, but I couldn't see the red spot. I guess it's right behind it right now. I didn't look at it, but when I magnified it further, right, to 100 times, and then it was much more clear and visible as well. So it's always a pretty object. Saturn and Jupiter are my favorite ones.
Yeah, and even with binoculars, they can be really excellent. And the warning against pointing things at the sun also goes for binoculars, definitely. Things have been set on fire with with the optics easily in the past. So if you've ever watched a survival movie and somebody started a fire with their glasses, that's what your telescope would do if you pointed at the sun. So just be careful with your eyes, folks.
And the interesting thing about that burning is it doesn't pain, right? So that's the worst part of it, right? So
Oh yeah, your eye doesn't have pain receivers in it.
right, right.
Apparently, I've never tried to look directly at
I
the
have
sun.
never tried it.
I suspect it would give you at least a headache, but you can do some very serious damage to your eyes with sunlight. So don't do it. For sure. Now, I just want to give one extra little heads up. So some of folks might not be as familiar with telescopes and optics as we are. So if you have a small telescope or a large telescope, one of the things that often is mentioned to describe how powerful a telescope is the F number. And I think you mentioned that, Mahesh, you had an F10?
F10, yeah, that's correct.
So F10 is not just a button on a keyboard. It's actually the measure that we use in telescopes, but also can be used for binoculars and other optics. It says what's the ratio of the system's focal length to the diameter of the entrance pupil, which is basically a fancy way of saying how much light can your system bring in? How much of a light bucket can you soak into the system? How big is that optical pipe that you're using to pour light down into? So the larger you have for your entrance pupil, obviously you can pull in more light, but you also have to deal with your system's focal length. And so you have some things occasionally where you have extremely short focal length systems, which are done to prevent telescopes from being as they used to be, which was many meters in length. So you'd have telescopes that ran up the sides of buildings in olden times. So it's a little bit of fun, but also a little bit of a fun aside for a smidge of history, I suppose.
Yeah, it's an interesting point. So mine focal length is 2000, but the diameter is 200. So it's F10, right? So 2000 over 200 makes it F10. And that's what the Celestron 8 inches. 8 inches, 200 centimeters. Yes, yeah. So 2000 centimeters over 200 centimeters gives me F10. And is that right, Elena, that if you have a lower F, the clarity will be much better? Is that?
It depends on a lot of things in your system. Your focal ratio, your F ratio, your F stop. You can really do a lot with it in different systems. So how you might set up an f stop for a camera would be maybe a little bit of a different consideration than setting up your focal ratio for a telescope. But there are certain tricks you can definitely play to try to bring the image in with good resolution, and make sure you don't get things like the light responding slightly differently at different wavelengths, which mean like colors kind of blur. There's a really nasty one called chromatic aberration that's can be a real problem. So there's all kinds of fun things to watch out for. I suppose we could probably spend quite a lot of time just talking about the optics, but but yes, the long answer is it can be, but there's a lot of other fun things to consider too if you're going to build it from scratch.
Perfect. Okay. Okay. Yeah. No, that's good. Good information.
So we have, of course, as you said, the Venus and Jupiter conjunction lining up here. And Mercury at greatest elongation, you mentioned it. You said you saw Mercury actually very visible just the other night.
Yeah, last night actually I did see it, right? Because my stellarium was pointing to that, and then I could see a dot over there. Hopefully it's not one of those planes or something like that which is coming towards us, but I could see it, right? And it was hiding. It was pretty stable. So I know it's 90% sure it's Mercury. All right, let's put it that way.
Yeah, it's pretty identifiable usually, and it is fairly bright once it gets away from the sun.
Correct.
And of course, we also had, potentially an even better situation coming up in, I guess, 14 days, or June 15th. Mercury at greatest elongation east. This should be even more spectacular, but it won't put it in quite the position where, for example, we could point our 1 meter telescope at York, because a lot of these large telescopes have limits onto how far down they can point on the horizon. So they like to point straight up ahead. But Mercury is never, well, I'll say never, but it's very unlikely that Mercury could ever get straight overhead. Something very, very serious would have to go wrong with the solar system for that to happen. It's not outside the realm of physical possibility, but it's extremely improbable. So because it's still so low, even at its farthest point, so whenever a planet, any planet, not just Mercury, is at its farthest point from the sun, from our point of view on Earth. So we're standing on Earth, going around the sun, looking back, and at certain angles, any individual planet will appear in the sky as far from the sun as it's going to be for us. So in the most extreme case, it's a planet like Saturn or Mars or Jupiter that orbits outside of us, so that from Earth you could have the sun shining on one side and be on the night side looking at the planet on the other. But that's never going to happen for Venus or Mercury, because they orbit interior to Earth's orbit. So if you have, a farthest separation, that's going to be the point where you can get the best view of Mercury or Venus through a telescope, especially. And what they do is they measure in degrees, and they look at the angles between the sight lines from observers to each different object. So you have elongation being actually a separation in degrees in the sky. It's pretty fun.
And the interesting that you mentioned that is because Mercury and Venus are inferior planets. Not that they're really inferior, but they're inside. And Jupiter is superior. It's outside our orbit, right? So, but when you see in the sky, they all line up together, and I can understand why our like I should say, our ancestors would have seen them all lining up together and going together. So they are in totally different orbits, right? So it's amazing to see that, right? And though you can see them line up in the sky, they are still, two are inferior and one is superior, right? And so it's an amazing view.
Oh yeah, and it's interesting to note that the Jupiter and Saturn, they are a lot easier to get good images of from ground-based telescopes, but there is something that Mercury and Venus can do that no other planet can do, and that's actually transit. So transit in front of the sun, which is a very fun thing that is not very common. I think the last one was quite a while ago, and that we do not have to look forward to, but that's when either Mercury or Venus, it actually goes across the surface of the sun, and you need special viewing equipment. But if anyone ever says you're at 0 degrees elongation, that means it's really right in front of the sun.
So did I use the right term, superior, inferior planets, or is it?
There's a different, there's actually several different ways of dividing up interior and exterior, inferior, superior. I've heard several, so use your own favorite, I suppose. You could go rocky planets, gas planets. That's also a common way to divide up which planets are where. Or we could just call them by their names and say...
why not?
Yeah, we'll just say Venus and Mercury. And the Venus, which is orbiting closer to Earth and a little farther away from the sun, it can get about 45 to 47 degrees high. And we measure these degrees in the sky from the horizon to straight overhead. So 0 degrees would be a flat horizon like the ocean, and then 90 degrees would be straight overhead. And Venus can get up to about 45 degrees, but Mercury, I think the highest Mercury greatest elongation was 28 degrees,
Wow.
which means it's just really, really low on the horizon.
Uh, that's uh, since we are on the topic of the planets, when I look through the telescope, I usually see Venus as a like a crescent, but I
Yes.
saw a full Venus. Uh, I think that's because it's the sun is shining right on top of it, right? So I could see it completely rather than a crescent that I usually see it as.
Yeah, so the nearly full phase of Venus is basically a gibbous, I guess. So if it's completely full, it's on the other side of the sun, which we won't be able to see. But it can get very close to full. So it can
Yeah,
basically
close to
go
full.
through the same phases as our moon. It's got a new phase where when it's actually gigantic and we can't see it. So if you have a very, very good telescope, you can just get the outline of Venus in its new phase. And then of course it has a crescent phase, and then it sort of gets sort of a waxing crescent until it becomes sort of gibbous. And just like the moon is almost full, it gets that kind of like sort of sliced off circle shape. That's when it actually is the smallest in the sky because it's just about to go behind the sun compared to us, and it will never be completely full.
And that's the reason for actually, I think I must have seen almost the full face, like or that kind of a thing, because I was quite surprised with the non crescent look of Venus, right? Usually that's what I get.
Yeah, the crescent
Oh,
phase
thanks for the explanation.
is big and popular.
Yeah,
So as you're watching it go around, as it's coming out of its new phase, it gets this very, very large crescent,
crescent. Yeah.
which then gets smaller and smaller and fuller as it goes towards the back end of the sun, from
Yeah.
our perspective. But Venus is really quite interesting because its phases are so big and bright. Mercury does have phases as well, and they're similar, but Mercury's smaller, harder to see, and it is really, I will say, it is really, really tough to get a good set
Face.
of Mercury pictures. I have not been able to do it. I have three very bad Mercury pictures at the moment.
Um, so hopefully one of these days hopefully one of the nights I can capture Mercury on my, like I can get a picture of Mercury on my telescope, right?
Yes, I'll
So I'm
just
just waiting for that. Yeah.
absolutely. And if anyone listening has a really wonderful picture of Mercury's phases, please do feel free to send them along. It's,
It's
um,
the one thing I just wanted to add was when Venus transited Sun, I used a solar filter to actually look at the transit, right? And I got the pictures of those. Just that I don't know where I kept it now. So that's the thing, and I could see it transit like dots in front of the sun. That was an amazing feeling when I. So those are my wow moments, kind of a thing.
yeah, those
But how
are
do you think?
those are quite rare. Yeah, it was the last was that the 2012 transit?
2012, I think. Yeah, that's
Yeah.
when it was.
So that was the big one. So they tend to occur in pairs. We had one in 2004, which I missed completely, and we had one in 2012, which I fortunately did catch. And I
Oh,
have
cool.
I have some very bad news for anyone listening. If you did not catch Venus's transit in 2012, the next pair of transits for Venus is in 2117.
Wow. Okay. Just wondering how old
2117. Yeah. So
I will be.
20, well, this, I'm like, what year is this? 2026.
Yeah, okay.
So if you missed this one, it's quite a while until you get to the next one. And of course, historically, they were used to do estimates of the solar system Johannes Kepler predicted the 1631 transit,
Hmm.
and there was all kinds of efforts to use them to get the true size of the solar system. So, get the actual distance to the sun, because people did not realize
Correct.
the sun is actually really, really far away, you guys. And getting accurate distances was really tough. And so they had, the 1631 and 39, I think it was. And it took quite a while before they were able to get sufficient transits that they could make those measurements and make their first estimates. But all of us who are around in 2012, if you got to see it, then you feel a little bit special, I think, because keep those photographs, because it's going to
Yes.
be a long, long time until they come back, the transit of Venus.
And it was measured in Australia, right? Like, so two different places. That's how they were
Yeah,
able to
that's
find.
you need two very different locations on Earth to make your measurements, and then they used parallax, which is
Parallax.
a very fun little geometry problem. It's actually one of the most, I suppose, easy equations in all of astronomy. So yeah, it's just a fraction. So it's really quite a simple calculation once you have the right positions. And because you're both on planet Earth from two different distances, and you're observing the transit, you can accurately say that you're both seeing the same thing. So there was a whole fun adventure story if people want to read about it. Edmund Halley and the 1716 transit. I think that was the one that was in Australia, but I might be mixing them up.
Wow.
I know there was a one in 1769 as well. So the 1700s, um, were an interesting time, and I know that in the last 1700 ones, the 1771, um, that's when they kind of used their transit data to make that actual distance calculation for how far is it from the Earth to the sun. And once you know how far it is from the Earth to the sun, and you know the size of the sun in the sky, then you actually know that the sun is ginormous. So it really expanded the scale of the solar system in a fundamental way. Great fun.
Okay. No, that's good. Great information. So, yeah. Um, Actually, I'm very interested with planets nowadays, so that's the reason I brought it up. So,
Well, thank you. This is a really fun sky chat so far. I did get a little bit inspired to look at some rocky objects myself. I found a bit of a fun one, so I might just talk about that a little bit before we do our reminders. So one of the other things we can think about when we look up at the sky is not just planets, but other rocky objects, smaller ones, the things called meteors, or if they hit meteorites, asteroids. These small rocky objects are incredibly numerous. And early in Earth's history, early in the history of the solar system, they were all over. We had a lot of impacts early on because there was a lot of stuff. And as it all crashed into each other, there became less stuff concentrated into various areas. And it's fun noting that even in recent times, we've had some really interesting asteroid and meteorite detections. The game of finding asteroids and asteroid prediction and being able to say that we see something in space that we think is coming down, this is something that we have only recently gotten really good at, but it has been known to be an issue for a while. Because what would you do if you weren't, a Bruce Willis Hollywood movie or whatever, and there's an asteroid headed to Earth?
uh,
What's our plan? And so
Armageddon.
Yes, Armageddon. I think that was one of the Deep Impact was the other one. There were two movies
Oh,
back
Deep
to back.
Impact. Yes, that's true.
One of them definitely had Bruce Willis in it, but it was, it's something that actually is a concern because we know these large rocky objects are out there, and we can now finally, with a lot of advances in telescope technology and in computing technology, we can watch the skies more accurately. And so I did actually find one for a little miniature, this week in history. There was, just a few years ago, so on June 2018. So 20, just a few years ago. It's 2026. It's almost 10 years ago. But my sense of time is wrecked.
Time flies. Yeah.
Yeah, time flies. So tomorrow, but in 2018, the 2nd of June 2018, there was a survey, Mount Lemmon survey, which is, I believe, still going, which detected an asteroid, a 2018 LA, and its official name is even worse, ZLAF9b2. It was a small asteroid, so this was only 2 to 5 meters across. So this is pretty tiny, dark thing to find in outer space. But they were able to identify it, find it, and show that it had an 85% chance of impacting Earth. And sure enough, after the impact, they got a fireball report from Botswana, and that fireball report went to the American Meteor Society, and then they went ahead and did Atlas observations with the Atlas telescope for about an hour to 4 hours to show that the asteroid had impacted Earth in southern Africa. So they actually closed the loop on the fireball report, and this was the third natural object confirmed to impact Earth, and that they were able to sort of identify in this confirmed way. Obviously, there are craters all over Earth that have not been identified, but this one was notable for me for a couple of reasons. First of all, I've been to Mount Lemmon. It's in the US. It's pretty fun. And second of all, the fact that we can now actually find these and identify them, and have a chance of knowing what meteor or what size meteor is coming down, and maybe even where it's going to land before it hits. And if you get them far enough away, then of course, and we'll probably talk about this a little bit later, there are actually plans on how to deal with them. So asteroids and meteors and meteorites now actually have kind of an interesting, I suppose, a more dynamic and interesting area of astronomy because we can do so much more with the detection and the prediction.
Yeah, it's survival mode. We are in survival mode, I guess, now that we know about it, right? We didn't know about it before, and so we were happy with it. Now we can actually see it coming down. There was one in Russia too, right? Like it just went through and then broke the window panes and like the glasses and things like that, right?
Oh
That
yeah,
happened.
yeah, yeah. That was fairly recent as well.
Yeah,
I
that's
don't
right.
remember what year that was, but there are some very impressive videos online showing the aftermath and the shock wave that went out, breaking
Right.
windows, setting off car alarms, and yeah, it's something to think about when we talk about meteors and asteroids, because a lot of us are familiar with things like the yearly meteor showers for 2026. In May, we had the Eta Aquarids. If we wait until August, we got the Perseids coming in. And these things tend to come from either asteroids or comets. And they are little tiny chunks of gas and dust and rock and ice. And depending on which one it is, it'll have more of one or the other, more rocky, more icy. And they come in and, occasionally bigger chunks do come off and you get bolides, and even bigger chunks come off when they leave little craters in the ground. So, we have these kind of very interesting different sources of entertainment in our sky at the moment.
These Perseid meteors are from a comet, is it? Like they've been, and it's already disintegrated,
Yes.
and then you're just getting the dust particles into it. into
Yeah,
our.
the Perseids in particular, those are the ones coming up in August. They're probably one of the brighter meteor showers of the year, and they do tend to occur every year. It's as the Earth travels through the trail left by the comet Swift-Tuttle. That's what it is, and it's got little tiny space debris for the most part. But yes, there are, I forget which was the one. Anyways, each one
Yeah.
comes from a different source. So if you hear Perseids, Lyrids,
Yeah.
Quadrantids, Quadrantids is a fun name, and that's an asteroid. So Quadrantids is asteroid 2003, I think. So it's one of the newer ones. But the Perseids are a comet, which is really just an asteroid with a bunch of water and dust around it.
And it's named Perseids because we are looking at Perseids when when we are going through that section of dust, right? When the
Yeah,
Earth goes through it,
it's
we are looking at
exactly
Perseids.
that's the where it looks to be coming from as the Earth travels in that direction. So the Earth is, traveling around the sun, and at some points various constellations are more or less visible, and so this dust trail that was left for the Perseids is laying in three-dimensional space, and as we fly through it, it looks to us like it's coming from the constellation of Perseus. It's not, but it looks that way to us as we run through it.
Yeah. Interesting.
All right, so I should probably do our halfway reminder for everyone. We're a little bit past halfway, but this is our little soundbite reminder. Everyone, thank you for listening to York Universe. We are currently broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you'd like to find out more about us, join our free Wednesday night tours, or of course, buy some tickets for Astrofair. Our website is yorku.ca/science/observatory. We're, of course, available over on social media for chat and questions and content. If you're tuning in live to the OPV, you can ask questions during the live stream. And of course, tonight we are discussing rocky objects and stargazing and things in the sky. If you have any other questions about this show, you can always email us at observe@yorku.ca. And of course, I'm joined this evening by Mahesh for our special guest. Mahesh, thank you for giving back again and talking about all things astronomy. We have all kinds of great topics that we've covered so far. Now we have a little bit of a reminder to people who are interested in the free weekly tour at the Allan Carswell Observatory in Toronto. If you are planning on attending the free tour this June, please note that atrium tours have been moved. They have been moved to the observatory. So we are not on top of the Arboretum parking garage because it is under construction. So if you are planning to attend the free tour on Wednesday, anytime in June, please go to the observatory, which is in the Petrie building, and do not go to the atrium or the Arboretum parking lot. Now, the next announcement I have is something that I'm sure everyone has heard about on this show before, but Astrofair is returning to the Allan Carswell Observatory for 2026. That's right, it's 2026. So we're running a bit of a yearly fundraiser to help support our student hours and to do some repairs. As you know, we are largely volunteer run, and so when we need to fix something, we tend to try to fundraise for it. We have one yearly fundraiser, and that is Astrofair. It will return this year, August 29th, 2026, from 6 p.m. to 11 p.m. This year, we will have an ice cream truck, and we have already confirmed participation by, of course, many, many popular booths from last year. We had all kinds of, we had the visible neutrino display. We had, of course, Rask Toronto Centre joining us, Space Place Canada, the Dunlap Institute, and Astronomy in Action is coming back, this time with We're bringing 1 to 2 planetariums. The observatory will, of course, be open. There will be activities for kids, lots of free giveaways, coloring sheets, and lots of telescopes. If it is cloudy, we will be inside the Life Sciences building and lobby. And if it is at all clear, some of the telescopes will move outside as well. But everything will happen on August 29th. Tickets are only $30. 100% goes to support either making this event happen or the observatory itself. It's actually split 3 ways. And of course, if you do get your tickets now, you'll have your spot guaranteed. You can go to all the booths as many times as you want. We are also looking to welcome people to the 8-meter stairs sundial, which will be being installed this summer just in time for Astrofair on August 29th. So hope to see everyone there. That's our that's our last announcement.
Yeah, that sounds cool, Elena. Like to have that Astrofair last year, I was there and it was a nice event.
Well, we're planning on making it even better this year. So hopefully we get lots of fun, lots of people coming in, and bring your families. As you say, Rask Toronto Center was one of our, you were there for the Rask booth last time. I remember you guys had your telescopes out. It was really, and the star charts too, right?
Yeah, we hope to this time as well.
Wonderful.
So,
so we hope everyone comes.
It's a nice event. Yeah, like personally, I thought it was great with the different booths there, right? So each addressing its own topic, and I think it was wonderful. And then we actually had a good sky as well. That night sky was pretty good.
Yeah, and we'll have, this year we're actually bringing in, it's the Ice Cube neutrino model display. So if you've ever wanted to see a neutrino, which is impossible, you can come and see the impossible. The neutrino display is definitely coming back. And we're working on getting straw rocket launchers. So if people want to launch straw rockets, that will also be available this year.
Wow. Fireworks? No, hopefully not.
Not indoors. No, we're safety first. Anyways, should be tons of fun, and $30 is less than a movie ticket and popcorn. So, I figure hopefully it's a good deal and fun for everyone. Now, let's go into some fun astronomy news. There has been so much going on. I'm sure we will not be able to cover all of it, but let's start off. Actually, maybe we'll start off. Let's start off with mine first, because I was just talking about meteor impacts. So how about I do number 2, and then we'll talk about Psyche. Let's see here. So in the news, if you have been watching the news, or even if you've just been sort of scrolling it on your phone, you would have heard something like Ontario skies lit up in the last couple of days. So this is just a few days ago. There was a meteor captured streaking across Ontario in Canada. And, it's a pretty unusual sight. It was sent to the CTV news station. Basically a driver who was driving around, I believe, south of Bloomington. He saw this flash, and he was driving to work at 5 a.m. So I was like, oh man, this poor...
Tough job. Yeah.
That's a tough job. But as a bonus, his dash cam caught this bright fireball, which is really a bright meteor. So the fireball came in over Lake Erie and landed, actually not in Canada at all. It landed in upstate New York across the border. So it flew across the sky in Canada, then landed south. And the nice thing about it is, because the tracking systems have gotten so good, they were able to tell that it was going to land across the border, and they were actually able to get a size estimate, as well as figure out where it came from. So we talked a little bit about, there's bunches of rocks in space still, not just planets, but little rocky objects. there is something called the asteroid belt, or the main asteroid belt. And this is where sort of we have in the solar system a concentration of asteroids and small rocky bodies. And the way that things get concentrated in the solar system is that basically stuff collides, and after everything that has or could collide has collided, what's left is what you have. And that sounds a little strange, but if you've ever had like a whole bunch of pool balls and you just threw them all on the table and had them all whack against each other, in the end, there's like maybe two left at some random position, right? So we kind of have that, but in the solar system, there's also a very strong shaping force called gravity. And what this has meant is that in our solar system, we have the inner solar system with our rocky planets, our Venus, our Mercury, our Mars, our Earth. And then we have a kind of a belt, a ring of small rocky asteroid things. And this is called the main asteroid belt or main belt. There are other little bunches of asteroids at places in the solar system, but the asteroid belt is sort of the main concentration for our solar system, and in particular the inner solar system and things that could come to Earth. So it's between Mars and Jupiter, and it really is a whole belt. It's like a ring, a toroid. And people were quite worried when they sent off the first spacecrafts out to Jupiter because they thought that things would collide. But turns out they're so small and there's so much space in there, you really don't have any chance of collision. Now, there are a lot of interesting things in the asteroid belt, but one of them was this object. So this exact little tiny asteroid bit came in from the main asteroid belt between Mars and Jupiter. It got knocked out or something, and it was going 50 times the speed of sound, velocity-wise.
Wow.
And it hit, it went across, it made a bright line across Ontario and went and hit upstate New York across the border. But the good news, and this is very good news, it was only the size of about a softball or a baseball. It was pretty small. So it took quite a long time for it to get here. It wasn't that big. It's, if you've been watching the Blue Jays, play one of those, but going a lot faster. And it ended its life spectacularly. But because it was so small, it wasn't really a big danger. So at that tiny size, the chance of it hitting a house or something is very, very small. I wouldn't say it's never happened. I believe it was the 1950s. An actual person had an actual little tiny piece of an asteroid, a meteorite come in and go through their roof. But it's very, very, very unusual, especially if it's that tiny. You just have to be incredibly unlucky to have it cause damage. But this is just a few days ago, so.
Okay, that's interesting. That's very interesting. And so when it landed, it was the size of a baseball, was it? Or when it entered the atmosphere, how did they judge the size?
Oh, they're saying it was about the size of a softball, baseball when it started.
Oh, when it started. Okay.
I do not think, at least none of the reports that I've seen, and they could still be searching, but none of the reports I've seen from CTV or the news stations have said that they found any impact or crater.
Okay.
But it's always hard to say if it did land in a body of water, a lake, or something. You're never gonna know.
Yeah, but traveling at the speed of 50 times the speed of sound, even a marble would be pretty destructive, right? So it will just go through the roof, or
yeah, if it did hit something, it would make an impact for sure. That's it's faster than a speeding bullet, as they say.
Yeah.
But these things do happen, and I do recall it was either last year or the year before last. There was an excellent bolide meteor that came through, and was caught on the cameras for the CN Tower in Toronto. And
Wow.
so, yeah, it was really exciting, and everyone was really keen to find out what happened. And it broke up and mostly landed in the lake. So
Oh, good. Wow.
it's like, well, the bad news is you don't get any
Yeah.
pieces of a meteorite, but good news is it didn't land on anything important.
Oh, and in Canada we have a million lakes, right? So we don't care, right? So it should possibly hit a lake, most probably.
Yeah, exactly. It's your chances of hitting a lake around here are better than most. And of course, we're always getting more of these pending fireball reports. Apparently, the Meteor Society gets lots and lots of fireball reports, and people just
Mm,
call them in. So, just as a little FYI, if you do see a fireball or a meteor sighting, you can actually call it in
mm,
and make that
that's
report.
interesting. Okay.
So, a little bit of public FYI. Now, as of course we get closer to meteor shower season, you can always hope that you'll get to see a bolide. They can be pretty spectacular with different colors depending on what the rocky body is made out of. Different chemicals burn differently in the atmosphere. And, we've got a little ways until the next one, but it's still quite fun to think about.
Yeah. Where would they call in, to report a meteor sighting? Essentially, is there a page or something like that they do? Is that? Oh,
It's the Meteor Association, I believe.
oh, okay.
I actually that's a good question. I don't know what their phone number, but the American Meteor Society is the name. So if you go
Okay,
ahead and
got
look
it.
them up, the
Okay.
ones that are listing the
Google.
sightings is the American Meteor Society,
Mm.
and I'm sure they have a contact email.
Yeah, yeah, I'm pretty sure. And no, that's very interesting though. I've never known somebody's actually gathering those information, but now that you mention it, actually, that's interesting too. It's a data collection thing, right?
Yeah, exactly. So, if you want to report it, I would say just go to their website,
Google it.
AMS Meteors. It's got to be on there.
Okay, yeah, that's good to know.
Actually, no, I just checked. They do have a big red button. It says, the big red button on the website says, report a fireball.
Oh,
So that's where you can go. And you don't even have to do an email. It's just it's a button you can report it from.
oh, that's cool.
Um,
Oh, uh, yeah, I was just wondering about was it Psyche or Psych? There was a, there's like what a probe
The
sent which,
Mars, yeah,
uh,
the Mars picture flyby mission.
yeah.
So this is a great one that's also been in the news. The Psyche is the name of a spacecraft, and it's spelled oddly, Psyche. So I call it Psyche.
Yeah.
I think that's probably an approximately right pronunciation, but this is a
I find it
mission.
fun.
Yeah. It's a mission to actually look at the asteroid 16 Psyche, which is a metallic asteroid. And it's been in the news recently because they just had a wonderful flyby, or they're going to have a flyby of Mars. Did they do it already?
Oh, they did. I believe they did. That's how I got to know about it, right? So they did
Yeah, they had
they
their
did a
closest approach.
they did the gravity assist using Mars gravity, and then they are just going. They are on their way to the asteroid belt.
Yeah, exactly. So they're on their way now, and they've taken the pictures, and it was just recently that they finished the gravity assist.
Mm.
They are not going to get to this asteroid until 2029, so it's
Mm.
still got 3 more years to go. But they did get to test all their instruments by doing a flyby of Mars. So they could test the
Yeah.
instruments, they could get new observations. They have a lovely picture of the poles.
Oh, really?
Um,
Okay. Mm.
yeah, and they actually went reasonably close to the Martian surface. So they using the planet's gravity as a slingshot, and that so they could reorient their direction and their velocity. So if you're trying to get yourself around the solar system, there's a very popular way to do it. It's called gravitational slingshots, where you use the gravity of one object to fling yourself around and gain velocity and shoot off in a new direction. So it's pretty interesting, and the Mars photos are excellent. So if you like more pictures of Mars, and who doesn't, I think they have been processed now, and most of them are up on the NASA website and probably other places.
Yeah, I would be interested. Yeah, I'd like to take a look at those. It'll be very nice.
I think my favorite of the Psyche pictures is definitely the ones of the ice cap. Just because I love how the ice caps always change a little bit on
Yeah.
Mars. They're really quite fun. And
It's still there, right? So hopefully it'll be there before we lose ours, right? So hopefully not.
well, it's supposed to arrive. You mean arriving at Psyche?
Yeah.
Yeah,
No,
yeah.
the Martian ice caps are still there, right?
Oh yeah,
I
well
guess.
they change every Martian summer, right? So you've got
Uh,
your water ice cap and your carbon dioxide ice cap,
okay.
and how much of it you get depends on which pole is pointed more towards the sun. And it's
I didn't
the
know.
the harder water ice cap is sort of underneath, and there's a lot of people who think that the subsurface water on Mars must be very substantial near the poles, and they've even
Okay.
done some really fun mapping showing where there could be kind of like trapped lakes of water under the surface of Mars, especially around the poles. I think it was just the North Pole. I'd have to go check my Mars maps.
So no, but that's an interesting point that you mentioned. There is all. I didn't know that there were two different ways. Like one was a carbon dioxide based, and the other one was the water molecule based, right? So that's interesting. Yeah.
Yeah, and Mars is itself an excellent rocky body. We would not want to get hit by it. We think we did get hit by something Mars-sized, which formed the moon very, very early on in the solar system. But the carbon dioxide, frozen carbon dioxide, is basically frozen dry ice.
Right.
And that usually goes on top of the water ice. And, both poles have a water ice cap. But the seasonal, like what makes it look really big is the seasonal accumulation of the carbon dioxide. So when that pole is at its winter, it gets an extra little carbon dioxide boost. And every time it gets recovered with its carbon dioxide layer, it always looks a little different, right? So every time you have a new season on Mars, you can always look forward to something new from the ice caps, which makes it very fun.
Wow, that's amazing. There is so much of information to learn from just one planet, right? So it's and so we take these things for granted. Once we see them on a telescope, we just say, "Oh yeah, I've seen it," kind of a thing. But there is so much of information associated with it. That's itself is amazing.
Yeah, and of course, this, as you say, the Psyche mission is itself really interesting because it did a great flyby of one really interesting rocky planet on its way to a crazy interesting rocky asteroid. Now, I think I had something else listed. Oh, right, the DART mission. But I just want to say before I do a quick recap on DART, I do want to just say about the Psyche spacecraft. It's on its way to this rocky asteroid, and they think it is a metallic asteroid, and it's got some very interesting properties. We don't have good pictures of this asteroid because no one has ever been close enough to get a good picture. But the actual asteroid is what's known as an M-type asteroid. It's the heaviest known asteroid. So you could basically say, okay, so this is like taking a cast iron pan versus like a snowball, right?
Wow.
So one of these things is really heavy, really dense. The other one's really light and fluffy. So 16 Psyche is the heaviest that's ever been found. And they think it might actually be an old iron core from a protoplanet. So some planet was trying to form, it differentiated like the Earth did, and all the really heaviest elements sink down into the core, just like on Earth. So we get the super, super heaviest metal core. But then maybe something happened to it. So if something had happened to it, you'd have this exposed core with all the outer parts stripped away, which would make this incredibly heavy object. And that's the current thoughts. This is not something that's been proven because, again, we haven't been there. But they think because it's so heavy and it's such an odd thing, this might actually be some sort of strange early exposed iron core that's had all of its outer layers stripped off or something somehow. Maybe the remnants of a really violent collision. But we won't really know until we get there.
Oh, that's interesting. Yeah, very interesting.
Really fun stuff. And of course, if something this heavy were to hit you, you would have a big problem because this is something, the more mass you have, the bigger the bang. So this is definitely something you would not want to get hit by. Okay. But good news is that it's not pointed towards us at all. So 16 Psyche is very definitely not in any danger of impacting the Earth. It's just it's very, very interesting asteroid. Yeah.
Oh, yeah. I'm pretty sure in future there'll be mining and things like that that's going to happen, which means there's so many metals that are going to be found on these asteroids, I suppose, right? So
yeah, well, and it's heavy enough. It's basically all metal. So in this particular case, 16 Psyche is, if you did happen to want like a whole lot of metal, you could just take this whole asteroid and be really well off.
Hey, Elena, is there gold in it? No, there'll be another gold rush, right?
Well, we do have to get there and find out. I mean, if they get there and see a solid gold asteroid, that would be.
Okay.
All right. So I think we'll go ahead and round off for here. Say I think a solid gold asteroid, maybe not, but but we might hope.
I meant one. Yeah.
And of course, if you do find yourself out and about and see a bright light in the sky, you now know how to report it. I'm going to go ahead and end off here for this evening. Thanks again, Mahesh, for coming on the show with me.
Thank you, Elena.
It's been really fun as always, and we do have to stop because we are running out of time. So thank you, everyone. You have been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. I have been your host, Dr. Elena Hyde, and I'm joined tonight by our special guest, Mahesh Aramudin. And of course, you can always find out more about the observatory and this program on our website, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, everyone, and have a good night.